let's look at differentiating inverse trigonometric functions. These are some key formulae that we will be using in the questions we look at. So the examples say find dy over dx for the following. Well, the first example is y equals arcsinx, the second one is y equals arccosx, and the third one is y equals arctanx. Starting with the first example, we have y equals arcsinx, which can be written as y equals sine inverse of x. We can now apply sine to both sides to give us sine y equals to x, since sine inverse and sine cancel. Now differentiating both sides with respect to x, on the left hand side, if we differentiate sine of y using implicit differentiation, we get that sine of y differentiates to cos of y, and then we multiply by dy over dx. And on the right hand side, if we differentiate x with respect to x, we just get 1. Now making dy over dx the subject, if we divide both sides by cos of y, we end up with dy over dx equals to 1 over cos of y. Now using sine squared y plus cos squared y equals to 1, if we make cos y the subject, then we get the following. So taking away sine squared y from both sides, we get that cos squared y equals to 1 minus sine squared y, and then if we square root both sides, we get that cos y equals to the square root of 1 minus sine squared y. And since we know that sine of y equals to x, then we can replace sine squared y with x squared, and so we get cos y equals to the square root of 1 minus x squared. Finally, if we replace cos y here with the square root of 1 minus x squared, then we get that dy over dx equals to 1 over the square root of 1 minus x squared. And so if we differentiate y equals arcsinx, then we end up with dy over dx equals to 1 over the square root of 1 minus x squared. Moving on to the next example, we have y equals arccosx. So firstly, again, we can rewrite this as y equals cos inverse of x. And now if we apply cos to both sides, we get that cos y equals to x, since cos inverse and cos cancel out. Now if we differentiate both sides with respect to x, then on the left hand side using implicit differentiation, we get that cos y differentiates to minus sine y, and then we multiply by dy over dx. And on the right hand side, if we differentiate with respect to x, differentiates to 1. And so if we make dy over dx the subject, if we divide minus sine y, we get dy over dx equals to 1 over minus sine y. Again, using sine squared y plus cos squared y equals to 1, we can then make sine y the subject and substitute into the equation for dy over dx. And so doing that, we get the following. Sine squared y equals to, if we take away cos squared y from both sides, then we get 1 minus cos squared y. And now square rooting both sides, we get sine y equals to square root of 1 minus cos squared y. And since we know that cos y equals to x, then cos squared y must equal to x squared. And so we get that sine y equals to the square root of 1 minus x squared. And so if we replace sine y with the square root of 1 minus x squared, then we get that dy over dx equals to 1 over, and now we have the minus sign here, and then we get the square root of 1 minus x squared substituted for sine y. So if we differentiate y equals arccosx, then we get dy over dx equals to minus 1 over the square root of 1 minus x squared. Now for the final example, we have y equals arctanx, and so this can be written as y equals tan inverse of x. And now if we apply tan to both sides, we get that tan y equals to x, since tan inverse and tan cancel. And now differentiating both sides, if we differentiate the left hand side using implicit differentiation, then tan y differentiates to sec squared y times dy over dx. And on the right hand side, differentiating with respect to x, x differentiates to 1. And now making dy over dx the subject, if we divide both sides by sec squared y, we get that dy over dx equals to 1 over sec squared y. Now using the fact that 1 plus tan squared y equals to sec squared y, we know that tan y is equal to x, and so tan squared y must equal to x squared, and so therefore this gives us 1 plus x squared, which equals to sec squared y. And so if we replace sec squared y with 1 plus x squared, then we get that dy over dx equals to 1 over 1 plus x squared. So if we differentiate y equals arctanx, then we get that dy over dx equals to 1 over 1 plus x squared. That is how you differentiate inverse trigonometric functions for arcsine, arccos, and arctan.